Hello, hello. This is section 8.2, part B. We're just going to call this day 2 on confidence intervals for proportions. We're going to continue where we left off yesterday talking about the recipe. Now, let's see if you know the recipe. Here's an intro example I'd like you to try. It says, a survey of 1,250 randomly selected U.S. adults found that 55% of respondents agreed that organic produce is better for health than conventionally grown produce. Construct and interpret a 97% confidence interval for the proportion of U.S. adults who think that organic is better. So why don't you take a second, pause, try it, see what you get, and then check it. See what you remember from last time. So I'm going to scroll down here. We talked about a 7-step process of going through this, and these are all the things that are good and expected when it comes to a confidence interval. And number 1 is stating what this parameter is. And this would be the P is to the true proportion of all U.S. adults who think organic is healthier. State your interval. This is going to be a 1 proportion Z interval. And check the conditions. Big one here. Is it a random sample of all U.S. adults? It was stated yes. Does it meet the conditions for showing a normal curve, the n times p, the large confidence condition, n times p and n times q hat greater than or equal to 10? Sure does. And is 1,250 less than 10% of all U.S. adults? Absolutely. Meets the conditions. Let's move on. Our formula, right here. Now, this Z value comes from a 97% confidence level. You can go to your normal curve and find the Z-scores that are the boundaries for 97% in the middle. You get 2.17-ish. So there is plugging in, crunching the numbers, getting our interval is step 6 right here. So we can then finish by interpreting step 7. At the 97% level of confidence, I believe that the true proportion of U.S. adults who thinks organic is better is between 51.95 and 58.05%. Now, what I want to talk a little bit today is what can we conclude based off of that? So, does that interval from Part A provide convincing evidence that a majority of all U.S. adults think that organic produce is better for health? Explain. I want you to think about this. Would that be enough information to give us evidence? Now, if you said yes, I would agree. Remember, a confidence interval is at a certain level of confidence, what is the range of all plausible values? Not possible, because anything's possible, but plausible. What should happen? And all of those happen to be above 50%. So a majority just needs to be above 50%. And this one definitely falls that way. So what are some things you're allowed to do with confidence intervals and drawing conclusions? So I want to make a couple notes here, worth writing down. Number 1, make sure to mention the confidence level, because it's definitely different if I said a 70% confidence level versus this 97. Okay, especially if it's close to 50%. By the way, if it was not all above 50%, I would not have evidence. Okay, because we'll get to that in a second. But use language such as I believe or is plausible, because, again, we're not stating facts. We're just using the data to make predictions or beliefs or conclusions based off of what we have. For specific values, if you're asked about a specific value, do we have evidence that exactly 50%? Well, in this case, we have evidence against it. We don't want to ever say we have evidence for. So even if we said 55%, I would say that that's a very specific value. We don't have evidence against it. It could fall in there. But I wouldn't say we have evidence for it, because it could happen anywhere within that 51 to 58% that we figured out there. So we're not proving specific values. Now, along with that, I've got 2 more bullet points. Confidence intervals do not give exact values. Again, it only gives an interval of plausible values. And each individual plausible value in that range is not more or less likely than a different one. So if this is my confidence interval, oops, I'll just go here, all the way to here. And I know this is my center, but it doesn't matter if it's here, if it's here, if it's right on the center, if it's over here. They are all equally likely because they fall in that interval. We do not have evidence for one being more than the other. All right? So there's some things we want to talk about with drawing conclusions. Now, one other thing that I want to add to this lesson is, what if we have the confidence interval and we want to answer some other questions about it? Like, I don't know what the point estimate is, but I know the confidence interval. Can I find the point estimate? Can I find the margin of error? Can I figure out what level of confidence was used? Absolutely. So keep in mind, from 38%, or in this case, it says a survey of 500 college students found that between 38.5 and 47.1% skip breakfast. So if I have 38.5, and up there is 47.1, what is my point estimate? What is right in the middle of that? And what is, should be switching to a different color here, sorry. And what is the margin of error? How do you find those? Well, if we know it's right in the middle, we can certainly do that. So the point estimate would be the average of those two. Right in the middle of 47.1 and 38.5, we can take 38.5 plus 47.1 divided by 2, and that'll give us our point estimate. And also keep in mind with that point estimate that that's not the only way you can find it, but that is the middle. That should be the center. It's not like that's like we said before, the one value we're looking for. It's still anywhere within this interval. So the other thing is you can put it as 0.385 and 0.471 if you want. Just be consistent. It ends up being 42.8% is the point estimate, or 0.428. Now, how do you figure out the margin of error? Well, if I know the point estimate is 42.8, it's got to be the same on either side of that. And it ends up being, I think it's 4.3. Margin of error is 4.3%, or 0.043. That's what would be on each of these sides, okay, to get us to those boundaries. Now, a little more difficult question is, what level of confidence was used to create the confidence level? So we do have to use what we just found. Now, based off of this, we had p hat was that, and this is the margin of error. This is our E. So think about our formula: p hat plus or minus z star, our critical value, times the square root of p hat q hat over n. This whole thing is considered our margin of error. Now that whole thing we know is equal to 4.3% or 0.043. So if we can solve it for the z, we can work backwards to find the confidence level. So if I took this and said, I don't know what z star is, but I do know what all this is. P hat, we said, was 0.428, which means 1 minus that will get us q hat, which is 0.572. We know the n. It was given that 500 college students. So we know everything, and if we solve it for z star, our critical value, we can get one step closer to our confidence level. When I crunch some numbers on my calculator, I get 1.94-ish. That didn't answer the question yet, but it does tell us if we have a normal curve, we are looking for what percent is within 1.94 and negative 1.94. We want to know that. So what you can do is you can go to your table, you can find the difference between the probabilities at 1.94 and negative 1.94. When you subtract them, that should give you the in-between. So 1.94 is at 0.9738. Negative 1.94 is at 0.0262. If I subtract those two, give me a second, I'm going to actually subtract those here. I have the answer, but I don't have the exact. It ends up being 0.948-ish, which we'll say is approximately a 95%. Oops, that looks like an 8. 95% confidence level. And that's what we would say. You can say 94.8, but it would usually we're dealing with whole numbers. Now, I do have other examples of confidence intervals you could do. Like here's one right here. If you wanted to pause it and try one, you can check my posted notes to see how you did. But I really just want to talk a little bit more about confidence intervals today, what you could conclude, and how you can work backwards with some scenarios. So that's section 8.2b. Day 2 on confidence intervals for proportions. We'll see you next time.